Welcome back. I'm going to work a number of problems combining the techniques that we've learned using Venn diagrams to test for validity and also rules, plus some review of a few other skills like moods and figures and schemas. So let's start with this example. All M is P, all S is M, therefore some S is P. So first, suppose I gave you this schema and said, what's the mood and figure? So to determine the mood, we list the types of propositions in this syllogism starting with the major premise. So that's an A, this is an A, and the conclusion is an I. So that's A, I, and the figure is determined by where the M's fall in the argument. So that is the first figure. So we'll write first figure. So the mood and figure is I1. Now let's test for validity using the Venn diagram approach. So I've already put a Venn diagram schema on the whiteboard. So our next step is to find and include the shading. So we have two universal premises. Both of these will involve shading. So first we have all M is P. That's obviously way too big. So let's fix that so it's usable. All right, that's going to be better. So we will shade the area of M outside of P. And then we also need, so that takes care of the major premise, we also need to shade the area of S outside of M to indicate that all S's are M. All right, excellent. So now on the Boolean interpretation, our diagram is finished. Why is that? Well, because we have two universals, they don't imply existence on the Boolean interpretation, so we don't need any X's. Now, you'll notice immediately that if this is a finished diagram, because there are no X's, then clearly there's not going to be an X to represent the S that is a P. So what that tells you is that on the Boolean interpretation, this argument is invalid. So what we'd probably want to write is that the Boolean interpretation is an existential fallacy. Now, it doesn't follow from the fact that it's an existential fallacy on the Boolean interpretation that we should write off the argument on the Aristotelian interpretation. We just have to finish the diagram and see, right? So to finish the diagram, we will assume that these two universal premises imply existence, and we'll look for definite X's. So is the M, for the major premise, is the M that is a P a definite X? Well, it would go in this region, and as you can see, that's not definitive because we don't know whether the X would go outside or inside the S circle, so we'll have to save that one. What about the S that is an M? In that case, the region of S and M would be this, right? Except part of it is shaded, and because of that shading, the only thing left is this region, so that is a definite X. Now, the question to ask yourself is, does that definite X do double duty for the indefinite X in the major premise? And the answer is yes. Why? Because this X, where it is right now, is not only an S that is an M, it also happens to be an M that is a P. That's why it can do double duty. So that means that our diagram is now finished. We've gone through all the steps: shading, definite X's, indefinite X's, double duty rule. Now, does the diagram as constructed require the conclusion to be true? Look what the conclusion says: at least one S is a P. So because this X does in fact represent at least one S in the P circle, the diagram as it stands requires the conclusion to be true. And so on the Aristotelian interpretation, this argument is valid. Now, we approach this example using a Venn diagram. You could also approach this example using the exclusion or the negation rules and the distribution rules, right? So how would that work? Let's start with negation. Remember, the trigger for the negation rule is if there are any negations in the syllogism, then something has to happen. Are there any? No. Because there are no negations, it automatically passes because it doesn't trigger the rule. So that takes care of the negation rule. What about distribution? We have two rules that we need to think about. The middle term must be distributed in at least one premise. And if we look at the major, what we see, because it's an A, we see that we have a distributed subject and an undistributed predicate. And because of that, we know that the major term is distributed in at least one premise. Just for completeness, let's look at the minor. It's also an A, but in this case, the subject that's distributed is the minor term, and the predicate that's undistributed is the middle term. So it's not distributed here, but again, because it's distributed at least once, everything is fine. The second distribution rule is if a term is distributed in the conclusion, then something has to happen. But let's see if that condition is met. Some SSP is an I. The distribution pattern for I is undistributed subject, undistributed predicate. So in fact, the rule isn't triggered because there's no distribution of one of the terms in the conclusion. So it passes the distribution rules, which we would expect from the Venn diagram, because the Venn diagram showed that it's valid on the Aristotelian interpretation. So if we had a mismatch, in other words, if the diagram said one thing and the rule said something different, then we've made a mistake somewhere, either in the application of the rules or in constructing the diagram. So this is the complete answer to this problem. We started with a schema, and we constructed the mood and figure. We did the Venn diagram for the Boolean interpretation and the Aristotelian interpretation, and we discovered that on the Boolean interpretation, we have an existential fallacy, which means what? It means universal premises and a particular conclusion. But we went on to apply the rules and discovered that there were no violations of the exclusion rules or the negation rule or the distribution rule. So this argument is valid on the Aristotelian interpretation. All right, let's turn now to another example. We're going to go through the same process, but maybe with slightly less explanation. So here we have a schema. The mood and figure is going to be I, A, I. And the figure here is the third figure. Sorry, I put the arrow in the wrong end. The arrow goes up if we use our little Y-shaped thing. So see, the third figure is subject, right? So that's what I intended to do there. All right, so that's the third figure. So we have the mood and figure. Let's do the rules first and then construct the diagram. All right? So is there an existential fallacy? Well, if you look at the premises, what we see is we have one particular and one universal, so it doesn't trigger the rule, meaning we don't have all universal premises, so we don't have to worry about what the conclusion is. So we're okay on that rule. What about the negation rule? If there's a negation in the syllogism, but there's not, all of these are affirmative, so it doesn't trigger the negation rule, so it automatically passes. Now let's think about distribution. Is the middle term distributed in at least one premise? Yes. Look at the minor premise. It's an A. The subject is distributed and the predicate is undistributed because the subject, and it's a third figure, because the subject is distributed. Because the subject is distributed and it's a middle term, then it passes the rule because the middle term is distributed at least once. As we saw in the previous example, we've got an I as the conclusion, and so the distribution pattern is UU, so it doesn't trigger the other distribution rule for the simple reason that we have no term distributed. So what does that tell you? According to the rules, the argument should be valid. So now let's do a diagram and see if we get the same result. So we have our schema. We need to put shading on. So we see that the minor premise needs some shading. So we will shade. We will shade for the area of M outside of S. And that's our shading. Okay, good. Now we need to include in the diagram an M. We need to look for definite x's. So we need to see if there are any definite. Is the M that is a P a definite x? Well, now notice it would be in this region, but because of the shading, there's only one piece of it left, which means it's definite. So the x goes here. And because the x is there in the diagram of the information from the premises, clearly it requires the conclusion to be true, because the conclusion just asserts that there's at least one S that is a P, and that's exactly what we have already in the diagram. So this argument is valid. Notice it's valid across the board. It's valid for the Boolean interpretation and the Aristotelian interpretation because there is no conflict of the Boolean and Aristotelian interpretation. Why no conflict? Because a conflict only arises if you have all universal premises with a particular conclusion. Any other combination is the same for the Boolean and Aristotelian interpretation. Okay, good. Let's move on and do another schema. Some P is not M. All S is M, therefore some S is not P. Okay, so first let's do the mood and figure. Our mood is OAO. And what is the figure? So again, we have the second figure because the middle terms are in the predicate position. So this is OAO2. All right, let's start with the diagram this time. Okay, so we want to do shading, and we have one universal premise, all S is M, so we're going to put shading on the diagram, the region of S outside of M, and our shading is done. Now let's look for definite X's. We need a P that is not an M. Where would that go? It would go in this region right here, a P that's not an M, because of the shading. And notice that region is bounded on all sides. It has nothing cutting across it. So the P that's not an M is a definite X. So we'll put it right there. Now, does the diagram require the conclusion to be true? Well, interestingly enough, the diagram allows the conclusion to be true, but it doesn't require it. Why? What would require it? There would need to be an X in this region of S outside of P, and there is no X based on the information we have in the premises, so that means the argument is invalid. Okay? Now, if the argument is invalid using a Venn diagram, then somewhere there's been a fallacy committed, right? So we've already established that there's not an existential fallacy. So let's move on and look at the negation rule. Are there negations in this syllogism? Yes. If so, there needs to be exactly one negative premise. That's what we have. One negative premise and a negative conclusion. That's what we have. So it checks out according to the negation rule. What about distribution? So first, let's look at the M's. Is the middle term distributed in at least one premise? Look at the major premise. In the major premise, we have an O, and the distribution pattern for O is undistributed subject, distributed predicate. So it checks out. The middle term is distributed in at least one premise. So we're okay there. Now let's move on to the illicit process rule. This is the rule about the terms in the conclusion. So the rule is if a term is distributed in the conclusion, then it must be distributed in its premise. So again, we just have to check. So this is an O. We have an undistributed subject, distributed predicate. The undistributed subject checks out because we don't have to worry about it. It's not distributed. But the P is distributed. And if the major term is distributed in the conclusion, it needs to be distributed in its premise, and it's not. There's our fallacy. This is the fallacy. The whole name of the fallacy is the fallacy of the illicit process of the major term, but what we'll normally do is shorten that down to illicit major. So this commits the fallacy of illicit major. Okay, good.